Ever feel like you're just drowning in data? I mean, from the news to your fitness tracker, numbers are absolutely everywhere. Today, we're going to pull back the curtain on statistics and see how it helps us turn all that confusing information into clear, confident decisions. Let's dive in. Right? Every single click, every purchase, every little measurement, it all piles up into this giant mountain of information. So the big question is, what do we do with all of it? Well, that's where statistics comes in. It's really the powerful toolkit we use to make sense of this constant flood of data, to find the actual patterns hidden in all that noise. And that really gets us to the heart of the matter. In a world that's so full of chance and variation and unpredictability, how can we possibly find reliable answers? How do we build that bridge from what we've already seen to what we can expect to see in the future? This is the fundamental question statistics is trying to answer. And I think this quote from Sheldon M. Ross just nails it. The whole point of statistics isn't just about some abstract math on a chalkboard. It's all about applying it to get real practical insights into, well, everything, from our everyday lives to really complex problems. So to do all this, statistics is kind of split into two main branches. You can think of them as two different jobs, really. One is all about describing what you can see right in front of you, and the other is about predicting what you can't. Let's break that down a bit. So first, you've got descriptive statistics. The best way to think about it is like taking a photo of a big crowd. You can describe exactly what's in that picture, how many people there are, what they're wearing. You get the idea. You're just summarizing the data you have. But then you have inferential statistics. This is where you take that same photo and use it to make an educated guess about, say, the average age of everyone in the entire city. You're using a small piece of information to infer a much, much bigger truth. Okay, but wait a minute. How can we possibly make that leap from a small photo to a whole city with any real confidence? That's a huge jump, right? Well, to do that, we need a special kind of engine, and that engine is probability. Probability is really just the mathematical language we use to talk about chance. It's how we measure uncertainty. Think of it as the crucial bridge that lets us get from one side to the other, from simply describing what we know to making some seriously powerful predictions about what we don't. And inside this world of probability, there is one shape, one single pattern that is more important than pretty much all the others combined. You've probably heard of it. We're talking about the normal distribution, but you probably know it as the bell curve. There's a reason it's called normal. It's because it shows up almost everywhere you look. It is, by far, the most important pattern for understanding how random things behave in the real world. You've definitely seen this shape before. Its nickname, the bell curve, well, it comes from its very distinct, symmetrical, bell-like appearance. You might also hear it called the Gaussian distribution, which is named after the legendary mathematician Carl Friedrich Gauss. Now, this perfect shape is defined by just two key numbers. That's it. The first one is the mean, which you probably know as the average. In statistics, we often see it represented by the Greek letter mu. This is just the center point of our data, the very peak of the bell. And the second key number is the standard deviation, which we represent with sigma. This one just tells us how spread out the data is. So, a small standard deviation means everything is clumped together, giving you a tall, narrow curve. A large one means the data is spread way out, giving you a short, wide curve. So here's the amazing part about the bell curve. This spread is incredibly predictable. There's a super useful shortcut for understanding it called the empirical rule. Or an even easier way to remember it, the 68, 95, 99.7 rule. First up, 68%. So what this rule tells us is that for any normal distribution, about 68% of all your data, the vast majority, is going to fall within just one step or one standard deviation away from the middle. Okay, so now let's take another step out from the center, 95%. If you go 2 steps or 2 standard deviations away from the mean in either direction, you've now captured a full 95% of all the data. This is huge. It means anything falling outside of this range is already pretty rare. And for our final step, get this, 99.7%. Go 3 steps out, and you have accounted for a staggering 99.7% of everything. That's pretty much all of it. This simple rule gives us an incredible amount of predictive power. Okay, so it's a neat mathematical pattern for sure, but so what? Why does this one shape matter so much? Well,
It's because this isn't just some abstract idea. It's a pattern that nature itself seems to absolutely love. As David Varodian puts it, it's the most important type because you see it again and again and again in the real world. So many things, if you just collect enough data on them, naturally start to form this beautiful bell curve shape.
And this is just scratching the surface. Think about it. The heights of people in a population, the scores on a test, blood pressure readings, even tiny variations in objects coming off a factory assembly line, they all tend to follow the same predictable pattern. It's almost like a fundamental signature of randomness that's just hardwired into the universe.
And that really brings us to our final thought here. If so many things in our world that seem random and chaotic, from our own biology to modern manufacturing, actually follow this one simple, predictable curve, it really makes you wonder, doesn't it? What else can we understand? What else out there can we predict?